Okay, hello, good evening, guys. Long time no see, shall I say? So welcome back to our. By the way, this is still April week 4, guys. April week 4, Hi, Jenny, how are you? Hi, Singdong, how are you? So this is still April week 4, We are not in May yet. Okay, not in May, because we haven't finished our week 4. So only next week we are going to April week. Sorry, May week 1. Okay, so we are continuing with this. I hope you still remember what you have learned before the holiday. Okay, we have finished what is your chromosome, your DNA, and gene. Okay, we finished this already. And what else? Oh yeah, what is your humans? We have 46 chromosome. If you're a XX, oh sorry, the first 44 or first 22 pair is your autosome. The last pair is your sex chromosome. It determines your gender. Okay, remember that? It determines your gender. And then, okay, we have finished what is your mitosis. Remember, we have two types of cell division. Okay, we have two types of cell division. Okay, let me write this here. Two types of cell division. We have mitosis and we have meiosis. All right, remember this? So mitosis is to create the same cell, as I mentioned here before. Okay, let me repeat this, guys, because today's stuff, we are learning about meiosis today, and meiosis is very related to mitosis. Okay, let me repeat this. Mitosis is to photostat the same cell. If you remember this, is to photostat the same cell. So mitosis is for growth. It's for replace. Like me, I do it. You do growth. Okay, see, me and you, we both do mitosis, but we do it for different things. You do it for growth, I do it for replace. And germs do it for reproduction. Okay, so like I said, you remember you, me, bacteria. You, me, bacteria, right? So we have four phases here. We have four phases here. We have prophase, metaphase, anaphase, and telophase. Remember I said PMAT? Okay, PMAT, Prime Minister Ada Telo. That's how I ask you to remember. And I ask you to remember 1 point for each, right? Prophase is when they are chilling. The chromosomes, they are chilling. Chromosome become visible. I did ask you to highlight this, did I? Okay. And prophase is to chill. They are chilling. Metaphase is when they are arranged at equator. And then anaphase is when they split into two. Okay, anaphase is split into two. And then telophase is when they reach opposite pole. Okay, so guys, before I move on, I want you to take note of something. You see prophase, right? I start with 4 chromosome, right? Can you see? I have 2 purple and 2 white. So at the end here, can you see I have 2 cells now? Each cell, I have 2 purple and 2 white, 2 purple and 2 white. 4 each. Can you see here? Can you see 4? That means I go from 1 cell, I create 2 same cell. Right? This is very important for growth. You see, do you change your face as you grow up? No, you don't, because you keep growing the same cell. Do I change my face as I grow older? No, I don't, because I keep producing the same cell. Do bacteria change as they reproduce? No, they don't. They keep producing the same cell. So what am I trying to say here is mitosis, their job is to keep creating the same cell, is to photostat the same cell. Okay, but let's talk about meiosis today. Okay, we should go back to meiosis. You guys ready to put this in? Ready to put this in? I hope you're okay to learn, because after this holiday, I realized that yesterday and the day before yesterday, Monday and Tuesday, my students have been, floating around, dreaming around. They couldn't really pay attention, right? I hope you are okay with this, So do let me know if you guys are, if I'm going a bit fast. Okay, guys, so meiosis, this is to create different cell. Okay, is to create different cell. Why do I need to create different cell? Because meiosis is only for gamete. Okay, meiosis is only for gamete. What is a gamete? Gamete is your sperm and ovum. Okay, 没有。Okay, so this is for sperm and ovum, meiosis. I don't want to say meiosis, I say meo lah. So meo is to create sperm and ovum. Okay, guys, think about this. Think about this. Every guy, they will make 100 million sperm per day. Right? Every guy, their testicle, okay, my testicle included, I will make 100 million sperm per day. And out of that 100 million sperm, okay, out of the 100 million sperm, you will not get 2 repeating sperm. You get what I'm trying to say? That means throughout my life, if I'm alive for 70 years, let's say, that 70 years of me making sperm, I will not get 2 sperm that looks exactly the same. Right? And in your case, okay, you two are girls, right? Okay, so you girls, you won't create 2 of the same ovum. Right? You see, you make 1 ovum every month, right? That 1 ovum you make throughout your life until you are 50 something years old, until you reach menopause, you will not create the same ovum. So you might say, sir, why is every sperm different? Why is every ovum different? Because your balls, girls have balls too, girls' balls, which is ovary, and guys' balls, which is testes, you will shuffle the chromosome. Okay, you will shuffle the chromosome. The shuffling part, it's called meiosis. Okay, the shuffling part is called meiosis. Can the shuffling part is called meiosis. So meiosis job is to create different cell, which is very important because, okay, let me ask you, do you guys have siblings? Do you guys have siblings? And do you know a friend who has like many siblings? Okay, I don't know lah. Do you have any friend who has like 5 siblings? And do they look the same? Have you seen someone's kids that look exactly the same? I mean, twins, even twins, they look a bit different, right? So why is it different? Because you see, every time you see different sperm, different ovum, you get different children. So that is your meiosis. Okay, so that is your meiosis. So you see, mitosis is to create the same cell, which is very important for growth. But meiosis has only one job, which is to do reproduction. Okay, which is to do reproduction. Okay, so this is a bit confusing. This is a bit confusing. Can you see like mitosis is like this, but meiosis is like this? Looks very hard, right? Looks very hard, right? Looks very challenging, right? Okay, actually, this is very simple. Meiosis is just like mitosis, but we do it twice. We do it twice. Right, you see, mitosis has 4 steps, right? Meiosis has 8. Okay, meiosis has 8. So why do I have 8 left? You see, this is meiosis 1, and this is meiosis 2. Okay, this is meiosis 1, and this is meiosis 2. So you see, meiosis 1, it's the same as mitosis. We have PMAT and PMAT. But this time I have P1, M1, A1, T1, because it's meiosis 1. And we have P2, M2, A2, T2. Can you see it's the same? It's just I do it twice. I have prophase 1, metaphase 1, anaphase 1, telophase 1, PMAT 1. And I have prophase 2, metaphase 2, anaphase 2, telophase 2, PMAT 2. Right? So you see, this is getting a bit simpler already, right? Okay, let me get Okay, is this hard for you guys? Is this hard? Are you guys okay following me? Jenny and Sintong, are you two okay? Okay, if you're okay, I proceed. I proceed. Okay, so let me make your job even easier now. Meiosis 2 is the same as mitosis. Right? Whatever you memorize for mitosis, it's the same for meiosis too. Right? Okay, so what did you memorize for meiosis? For mitosis. Prophase, chromosome become visible. Chromosome chilling. Metaphase, arrange at equator. They arrange. Anaphase, they split. Telophase, they reach opposite pole. And then if you go to meiosis 2, it's actually the same. You see? This one, they are arranged at, they are chilling. Okay, chilling, become visible. Okay, they didn't write it here. I can write the same for here. They become visible, right? And then for metaphase 2, can you see they arrange? Can you see they arrange? So chromosome arrange at equator. Same point, right? For anaphase, they split. So chromatic separate. Same thing. And then next, they reach opposite pole. Okay, they didn't say it here, but you can write the same thing here. They reach opposite pole. Right? So PMAT2. Can you see it's exactly the same? So meiosis 2, you can ignore it because it looks exactly the same as mitosis. Right? So you can just, whatever you memorize for mitosis is the same as meiosis 2, which is why in exam, very seldomly they will touch on meiosis 2. Because it's too simple. You get exactly the same thing. There's nothing to ask here. Right? So what about meiosis 1, sir? What about meiosis 1? Okay, can you see meiosis 1? They are doing something funny. They are pairing up. You see, this is one pair. You see, usually meiosis 2 is like alone, 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 alone. Same thing goes to mitosis. Alone, 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 and alone. But you see meiosis 1, can you see that like in one pair now? Can you see that in one pair, one pair, one pair, and one pair? So this pair, okay, please write down. This pair, we have a name for it. We have a name for it. This pair, we call it homologous chromosome. Okay, this pair, we call it homologous chromosome. Chromosome is one. Homologous means pair. We pair the chromosome. Homologous chromosome. That's the meaning of homologous chromosome. Okay, so that means, guys, to make your job even simple now, in meiosis 1, you can actually write back for mitosis. You just change your chromosome to become homologous chromosome. You remember what happened at prophase? Chromosome become visible, right? Chromosome become visible. So you just change a bit, homologous chromosome become visible. Same thing. Metaphase 1. Chromosome arranged at equator. Homologous chromosome arranged at equator. You just add another homologous in front. Anaphase 1, just now chromosome separate, right? Now homologous chromosome separate. You just add one more homologous here. And then telophase 1, homologous chromosome reach opposite pole. Easy? Easy? So whatever you memorize for mitosis, you can use the same for meiosis 2. Meiosis 1, you just change a little. You add a homologous in front because homologous is the pair. Okay? You see, you memorize one part, you can settle two parts. So tai, right? So tai, right? You memorize one, you get two parts. So very easy, huh? Very easy, huh? But wait, I have one more thing to add on. I have one more thing to add on. Can you see what are they doing here? Okay, sir, why your legs got changed on? This is a purple chromosome. Okay, this was a purple chromosome and a white chromosome. Suddenly, right? Suddenly, You see this purple chromosome, they have white leg. And this white chromosome has a purple leg. Eh? What like that one? Remember I said meiosis is to create different cell, is to shuffle your chromosome. Shuffling. If I need to play cards, I need to shuffle to get different cards, right? The shuffling is what we call crossing over. Right? The shuffling is what we call crossing over. Can the shuffling is what we call crossing over. Guys, please highlight this word. This is what they will ask for this. And when did it happen? This will happen in Phase 1. That's why I always ask my student, you want to study, right? You focus on Phase 1 will do. Phase 1 is our main concern because the main point is at Phase 1. Because the rest is so easy. You just add one more homologous in front. This one you just follow back. Nothing to ask one, right? But this crossing over, I do have some challenge here. Right, what is crossing over for? Crossing over is to shuffle, right? Shuffle is to get different cards, right? Shuffle is to get different cards, right? You see, if three of us, we play Chor Tai Ti, you know what is Chor Tai Ti? Okay, if we play Uno lah, whatever. Okay, if three of us, we play Uno now, we play for the first round, and then we collect back the cards, we shuffle again, we play second round. Do you get back the same cards in second round as in your first round? Do you get back the same cards? No, you don't, right? No, you don't. You don't get back the same cards. You every time you play your cards, you get different cards. So that is what we do crossing over for. And that difference, first round different cards, second round different card, third round different card. Every time the difference is what we call variation. Okay, the difference is what we call variation. The difference between you and me, the difference between you and your siblings, the difference between every humans. Can you find two humans that is exactly the same? DNA same, fingerprint same, look same, everything same? No. We have like what? 8 billion people in the world, right? We have 8 billion people in the world. Yes, there are like maybe a few that looks like you, but there's not one that looks exactly like you. This difference is what we call variation. We all have variation. Nobody looks the same, right? Because of the crossing over, right? Because of the crossing over. So you see, crossing over is the exchange of genetic information. Exchange, they shuffle, right? They shuffle. So the point is to make different chromosome, right? You see just now, I start with 4, I end with 4 each. 4 each. But this one, I start with 4, I end up with 4 different ones. So you see, short purple, long white, purple leg, long white, short purple, white leg, long purple, white leg, white short, long purple, white short, purple. What am I saying? See, everyone is different. Everyone is different. And can you see got 4? Can you see got 4? Why got 4? Because I do it twice. What does the length mean? It just means it's different chromosome. It just means it's different chromosome, right? So you see, I do meiosis 1, I get 2 cells. I do meiosis 2, I get 4 cells. Because I do it twice, so I get 4 cells. So you see, this is the difference, right? But my main point, guys, mitosis is to make the same cell, is to create the same cell. Meiosis is to create different cell. Different. I want to make different cell. Completely different. My sperm need to be all different. My ovum needs to be all different. Everything needs to be different. That is the difference. Okay? Can I? So who is more important? Both also important, but they serve different purpose. Mitosis is for you to grow. Meiosis is for you to make baby. Which is more important? Both also important, right? Okay. If I do a summary like this, let me do a summary. Remember this story? This is your dad. This is your mom. Okay? Your dad has 46 chromosome. Remember? Your mom has 46. Your dad will give you 23. Remember? Your dad's sperm has 23. Your mom's ovum has 23 also. So how does your dad choose 23 from that 46? This is your meiosis. Your dad will do meiosis to randomly take 23. Your mom will also do meiosis to take randomly 23. And when they combine, this process is called fertilization. Remember? Sperm, ovum, fertilization. And you create you. You start from a zygote. Remember what is a zygote? When you were in one cell, that is your zygote. You were one cell, you are a zygote. From zygote, okay, zygote is when your mom is pregnant with you. Now you are 16, right? Now you are 16, right? So to grow from zygote, this small zygote to you are such big size now. This process is mitosis. See the difference? See the difference? So which is important? Both also important. Meiosis is so that your dad can make sperm. Meiosis is so that your mom can make ovum. Mitosis is so that you can grow. Different case, different story, different purpose. So that's the meaning of meiosis and mitosis. Okay, easy huh? Easy huh? So hey, this one in biology they are learning in detail, and plus if you learn this in school they will drag this thing very long one. Like sometimes you listen to your teacher talk about this for 2 weeks and then you are still scratching your head like, I don't understand. You see, this is the summary for you. Takes me like what, few minutes. Okay, easy huh? Okay, let's do some exercise, shall we? Let's do some exercise. Oh yeah, before I begin, sorry. Let's go to the difference. Okay, I already sum up the difference for you here. Okay, so what about the similarity? What's the similarity between mitosis and meiosis? They both do cell division. Okay, they both divide. They both do DNA replication. They both photostat DNA. Difference. Where does it happen in mitosis? Like I said, it happens from your head to your toe. Your whole body will do mitosis, right? Your skin, your brain, your muscle, your wherever lah, your whole body will do mitosis. So your whole body cell, we call it somatic cell. Remember I said this? Your soma, semua, your semua cell, somatic cell, semua cell. Can? Your somatic cell. And then your meiosis will take place in reproductive cell. That means your testes and ovary, your sperm and ovum. Okay, your sperm and ovum will do meiosis. Only your sperm and ovum. Okay, so plants we ignore lah. Plants we ignore. Right. What about daughter cell? What about daughter cell? A daughter cell is how many cells do you get? Mitosis, I do it once. From one, I become two. So I have two daughter cells. For meiosis, I do twice, right? So like I said just now, you will have four daughter cells. Okay, four daughter cells. So you see, and then crossing over, this one you know lah, the shuffling. Any shuffling for mitosis? No shuffling. No mitosis, no shuffling, no crossing over. This one has shuffling, has crossing over. Genetic and variation is the same. Okay. What is genetically identical? That means exactly the same. Genetically, as in chromosome, they look exactly the same. Four chromosome, four chromosome. Two purple, two white, two purple, two white. Exactly the same. Genetically identical. So there's no variation. If me and you, we look the same, we are clones. We have no variation. Okay, something like that. But for meiosis, they are genetically not identical. They are not the same. That's why they have variation. Every sperm is different. Every ovum is different. Every human is different. Okay, can I already summarized everything for you. This one number of chromosomes, you don't need to care. Okay, you just need to know one is full, one is half lor. Something like that. Okay, so this is the difference. This is the difference. I already summarized everything for you. So let's do some exercise. Let's do some exercise. Let's I think we stopped around halfway right here. We did some, right? I think we finish question 3, right? Before we go. Okay, before we go for holiday. So let's go to, okay, let's do some meiosis one. Okay, let's go to question 6. Okay, let's go to question 6. This is page 17. Okay, page 17. So name the phases in meiosis in the chat below. Right, so what are your phases? You have PMAT1, prophase 1, metaphase 1, anaphase 1, telophase 1, and then you have PMAT2. Prophase 2, metaphase 2, anaphase 2, telophase 2. Of course, you can't name it in short form. You can't. And by the way, you think your exam will be so straightforward like this? Usually not, isn't it? Where got so easy one, right? So you'll get A. That's why. Wow, 4 marks there, you see. Okay, let's look at how your exam will be. Your exam will look something like this. Okay, your exam will look something like this. So, can you see meiosis? Read the question. Sometimes they will tell you either this is mitosis or meiosis. Okay, even if you don't know this is meiosis, you look at the pair, you know, lor. Can you see the leg got change color? If there's changing of color, that means there is crossing over. There's shuffling. Got shuffling means it's a meiosis, right? So name the above phase. What is this phase? What is this phase? Okay, let me teach you how to see. You see they are splitting? Can you see they are splitting? Whenever it's splitting, what phase is that? Yes, very good. So that's your ana. So that's your ana phase. And our meiosis has 2 ana, right? Ana 1 and ana 2, right? Is this ana 1 or ana 2? How do you see? Remember I said ana 2 is just like your mitosis. It's alone. But this one is not alone more. This is one pair. Remember what is one pair called? Pair is what we call homologous chromosome. Remember? Homologous chromosome. Homologous, whenever you have homologous, that means it is a anaphase 1. Yeah, I'm good. I just have some itchy nose. I don't know why. Yes, I'm cool. Okay, so this is anaphase 1. Anaphase 1. Okay, let me roughly teach you how to recognize. Okay, whenever you see a pair, it is for sure one. For sure one. If it is alone, then it is 2. Very easy to tell. So this is one pair, ma. This is one pair, ma. So it's a 1. Okay, it's a 1. So see, describe what happened in the above phase. So what happens here? What happens here? The homologous chromosome separate. Okay, homologous chromosome separate. What if this is meiosis 2? What if this is mitosis? You cover the homologous chromosome separate. Okay, you just cover the homologous. The homologous is only for meiosis 1. Right, so D, state one importance of meiosis. Now, what is the importance of meiosis? This is to create variation. Remember, me and you needs to look different. It's only for variation. Right? So next, state the phase shown. What is this phase? What is this phase? They are not doing anything. They are chilling. And they are in pair. Chilling is what phase? Chilling is what phase? Pro. Wow, very good. Chilling is pro phase. Pair is what phase? Pair is 1 or 2. Like just now, no? Pair is 1. Good. So this is pro phase 1. And just by looking at this, they are changing their legs, right? Pro phase 1 is the one we focus. What are they doing? What are they doing? So at this phase, explain the behavior of the chromosome. What is the chromosome doing? What is the chromosome doing? Okay, they are visible. Whatever prophase, you can also say visible one. And what are they doing? The shuffling is called? Yes, shuffling. It's called crossing over. Good. Okay, they are doing crossing over. All right. So name the process. This is the same question, crossing over. Okay. Same process. Explain its impact on organism if this process does not occur. What if there's no crossing over? If no crossing over, how? Okay, what is the job of crossing over? What is the job of crossing over? Crossing over is for variation, right? If there's no crossing over, if there's no crossing over, no variation. Okay, shuffling got variation. No shuffling, no variation. Right? Just like in your mitosis, any shuffling, any crossing over in mitosis, no. So any variation in mitosis, no. No shuffling, nothing. Okay, easy. Just like what I said. I mean, what you learn just now and you come to exercise, you might say, sir, this is a bit hard. That's why I'm showing you how to do. Okay, but it's not really that hard. State the animal cell that carries out the process of cell division as figured above. Who will do this? Which cell will do this? What cell will do this? You can say your reproductive cell. You want to say sperm or ovum also can. Okay, sperm or ovum also can. Right, things like that. Sperm or ovum. You want to say ovary and testes also can. Because it's our ovary and testes that makes the sperm and ovum. So ovary and testes also can. Right, easy, easy. Okay, let's do one more, shall we? Let's do one more. So this is your question 7. You see, you know lah, this is meiosis lah, you see. Got crossing one, got change leg one. This is meiosis, right? So, state the type of cell division. This one they ask you, they didn't say this is meiosis, but they ask you what is this? This is meito or meio. Obviously, this is meiosis. How do you know? Cause the leg got change color ma. Okay, got change color ma. That means that's meiosis lor. Give a reason for your answer. How do you know it's a meiosis? Cause crossing over takes place. If you say, sir, I don't want to write this answer, can. What else can you write? How many daughter cells here? How many daughter cells here? 4 daughter cells. When you see 4 daughter cells, this is for sure meiosis. So many you can write. So what is the process that is stage Q? Stage Q is here. Okay, they are arranged here. When you see arranged, that is for sure what am I saying? Metaphase. And then, is this metaphase 1 or 2? You have to look, is it 1 or a pair? This is a pair, right? A pair, right? A pair is for sure meiosis 1. So it's metaphase 1. Because just now, you see? Prophase 1, a pair. Anaphase 1, a pair. So when you see a pair, that is your metaphase 1. Okay, so number 2, what is the importance of the process stated in number 1? What is metaphase 1 for? Okay, no, we skip this. We don't usually ask metaphase, we usually ask prophase. This is a bit weird, you see. They are not changing their legs yet, but they are arranged already. This question, I think that's a little bit wrong one. Because if you ask me, sir, is this pro or meta? I will tell you. Oh yeah, if you just say meta, okay, guys, if this is meiosis, meiosis got 1 and 2, right? You just say the phase without mentioning the 1 and 2, your answer is wrong. Your answer is wrong. You must write the 1 or 2. Okay, so okay, the C and D is the same question one, so you can do it yourself. Okay, so this one fill it out yourself lah. Fill it out yourself lah. Okay, guys, let me tell you something very annoying. Let me tell you something annoying. This whole chapter, right? This whole chapter, what is the part that is least important? What is the part that is least important? Is actually this part. Mito and Mayo. Sir, I learned so much already. Only you tell me this. Yeah, because statistically speaking, I mean, because this is very hard for many students. I mean, you come to my class, I make it very easy for you, but you have to know for some other students, this is a very hard chapter. Even for bio student, they will think this part is very hard. So that's why you are taking science. Your teacher will try not to kill you, so they will not try not to come out with too much of this. Yes, they will still come out, but in objective, right? So you can tembak already. Hiya, sir, you don't say earlier, burn my brain only. Right. Don't kill me. This is what happened. Right. So anyway, let's look at 5.2, shall we? How much out of 100? You mean year-end exam? You might not even see, okay, you might see 2 or 3 questions in objective. Sometimes not even one. That time you'll be slapping yourself. You see, I don't make the rules. Don't punch me. Okay, let's look at 5.2. This is important. This is the most important part of this chapter. Okay, so let's learn something useful today. Okay, we have like what, 20 minutes. Okay, let's learn inheritance. Okay, what is inheritance? This is where we enter the main point. Inheritance in Mandarin is what we call 遗传. You know what is 遗传? Okay, inheritance is when your parents pass something to you, right? If your dad is very tall, he passed that gene to you, making you very tall. That is inheritance, right? So inheritance is the transmission of characteristics from the parents to the children, right? You will not run far away from your parents. If your parents, they look a certain way, more or less, you will look that way, right? You will not fall very far away from your dad or your mom. You just somehow look like them. It won't die. Yeah, it won't die out. Yes, right. It won't die out. So, let's look. Okay, I have 2 words I want you to know, which is characteristic and trait. They do refer to the same thing. Okay, but what's the difference? Right. Let's say eye color. Let's talk about eye color. How many types of eye color have you seen? And what are they? Okay, how many types of eye color? Huh? Yeah, they got mini one, of course. Okay, how many types of eye color have you seen? Okay, blue. What else? Green. Good. Brown. Black. Very good. So you have 4, right? So what's yours? What's yours? I believe most of us, we are Asian AF. If you are Asian AF, most likely we are black. Anyone with blue eyes here? No, huh? Then you are quite low already. No, not possible. Right. So out of all these choices, this is what you have. Right? So these choices are what we call trait. The choice that you have, is what we call characteristics. Okay, so trait and characteristic. Traits are the choices. Characteristic is what you have. That's the difference. Okay, can see the difference? Can see the difference? Trait and characteristic. So it's like tall and short are the traits. You being tall is your characteristic, right? Characteristic is what you have. This is what you have. So that's your characteristic, right? So as you can see here, characteristics are tangible properties that are inherited and determined by genes, such as the color of the pupil. Traits are the variants. I see variants. You see, like your COVID has many variants: alpha, beta, delta, omicron, are variants for specific characteristic. that differentiate individual. Example traits for the color of the pupils are black, brown, blue. All right, so that's the trait and the characteristic. Right, guys, your characteristic is determined, if you remember, by your gene. Remember this, right? You have your chromosome, DNA, and gene. Like I said, each part of the gene will determine one characteristic. Your eye color, your hair texture, hair color, whether you're single or double eyelid, whether you have dark or fair skin, things like that, right? So gene, okay, let's talk about gene. Let's talk about gene. Right, let me ask you. Some people, they will say things like that one. Oh, usually gene, you follow your mom's one. And then some will say, no, 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 gene, you follow your dad one, right? You follow mom one. So whose do you follow? Whose do you follow? Who do you think your gene follows? You don't know, right? You see? Sometimes you follow your dad. Sometimes you follow your mom, right? Maybe you have, yeah, both also got, right? Sometimes you have your dad's eye and you have your mom's hair, right? So in this case, you're like, who determines who leh? Right, which brings me to this point. You have two types of gene. Okay, you have two types of gene. We have dominant gene. You know what is dominant? You know what is dominant? Okay, among your sibling, who is the dominant one? You know, dominant? Dominant means 强势, the stronger one, the one that decides everything. Right? Like if you have a koko or 姐姐, right? He's the dominant or she's the dominant one. Every sibling will point to him or her one. Right? Like your mom will ask any of you, what should we eat today? Don't know, ask 姐姐. 姐姐 will decide everything one. So the oldest are usually sometimes dominant could be the youngest one. So dominant is the winning one. The strong one is the dominant gene. Yes, the leader, right? And then the other way, the other end, we have something called recessive gene. This is the losing gene, right? So this is the losing gene. Okay, what do I mean? That means, okay, like you see, your dad will give you one gene, your mom will give you one gene, right? Because they get from both, ma. Okay, let's say, your dad gives you a tall gene, your mom gives you a short gene. Will you be tall or short? So they will fight. They will fight. Tall and short will fight. The dominant will win. Who is the dominant? You see, dominant is tall, recessive is short. So the tall gene will beat the short gene, and the tall gene will win. And end up, you will be tall, right? So who determines which characteristic is not just your mom or dad? Oh, sometimes they say, dad for your eye follow dad one, your hair follow mom one. No, it's not like that. It's see who is the dominant. The dominant will always win, right? I don't care it's your mom or your dad. If your dad gives you dominant, your dad one wins. If your mom gives you dominant, your mom one wins. So see who's the dominant, lor? Who's the dominant? Dominant is always the winning one, for sure, right? So what is the dominant gene? It is genes which shows the characteristic that they control when paired with a dominant gene or a recessive gene. That means they will always show. Right? It is a gene that will always show. This gene, if you have it, it will for sure come out. Right? If your dad is tall and your mom is tall, if one of your parent is tall, you will usually end up tall one. Right? Because of the dominant gene. The strong gene will beat the weak gene. So you will have the dominant gene. Right? And then weak gene, they are only genes which shows the characteristic that they control when these genes are paired with another recessive gene. When you pair it with another recessive, that means there's no dominant gene, only they will show. When there's no dominant, right? When there's no dominant, only they will show. In this case, if your dad gives you a short gene, your mom also gives you a short gene, any winning gene here? No. Both also lose, so you'll be short. Right? So you see, gene, they also need to fight one. So you see, this is why okay, which brings me back to the story 2 weeks ago. You might say, sir, why my siblings they have better gene than me one? Because they get more dominant gene from the mom and the dad. You somehow got less. You see, because of the meiosis, remember? The meiosis is the shuffling, ma. Somehow when your dad shuffles, he gave you less dominant gene, or hopefully more, right? And then somehow your sibling got less, or maybe more than you, who knows, right? So like I said, everything is random. Everything is random. You cannot control. Whether you have more dominant gene or less recessive gene, everything is like according to chance one, right? Which brings me to this. Okay, usually, guys, dominant gene, okay, if I ask you to write tall, short like that, it's very tiring, right? So usually, dominant gene, we will use capital letter. We will use capital letter. Recessive gene, usually we will use small letter. Which brings me to this, right? If your dad gives you a big T, which is tall gene, your mom gives you a big T, which is another dominant gene, you have two dominant, for sure guarantee 100% you'll be tall. Because you have no losing gene. Both your gene also winning one. So in this case, we call you a homozygous dominant. What is homozygous dominant? Homo, do you know what's the meaning of homo, guys? Homo means same. Homo means same. Right? Homo means same. You know, homosexual? Homosexual means you like the same sex, lah. Right? So homozygous dominant. Okay, same. Right. What if your dad gives you a dominant gene, and can you see the small t? This is the recessive. Your mom gives you a recessive, right? In this case, you will still be tall because your dad's gene will beat your mom's gene. So you end up tall also, right? In this case, we call you a heterozygous dominant. Hetero means different, right? If you are heterosexual, means you like the opposite sex. You are a girl, you like a guy, you are a heterosexual, right? Like I am a heterosexual because my wife is a girl, obviously, right? So this is your heterozygous dominant. Okay, both also dominant, you see, because both also tall. It's just that one is big T, one is big small t. Can can easy usually my student will ask me, sir, I'm tall. Okay, I'm tall. So which one am I? Which one am I? This one I will not know one. Whether you are big small t or you are big T, we have no way of knowing unless you have the money and go and do DNA test. You go and do your DNA test, then you will find out whether you are big small t or you are big T. Right? Do you really care? Not really, right? Not really, right? So if you care, then you go and find out lor. Go and find out lor. But usually there's a way to tell. Usually there's a way to tell. Okay, let me ask you. Are you guys tall? Are you guys tall? As a girl, if you're 1.6 something, you're considered tall. Okay, okay, you are tall. Right? Sinto, what about you? Are you tall? Okay, if you guys are tall, tall. Okay, so you look at your parents, you look at your dad's side first, your dad's side, look at your grandpa, grandma, your dad, all your cousins from your dad's side. Are they tall? Are they tall? Okay. Then you look at your mom's side. Are they all tall? Average. Okay. If it's average or no, then most likely you are this. You could be this. I could be wrong. Okay. But I'm guessing you're most likely this. But if your dad's side, they're all super tall, your mom's side also all super tall, then for sure you are this. Because short gene doesn't exist in your family. Your family has no short gene. You are all giants. Right? So good for you, lor. You are all tall. Yeah, lah, giants lah. Okay, anyway, so if you look at, okay, what if you are the unlucky case, your dad gives you a recessive, your mom gives you a recessive, this one you cannot do anything already, you will be short, okay, or we call it dwarf, right? So this case, we call you a homozygous recessive. Why homo? Homo for same, recessive law, both also same short, same losing, same losing. This one is same winning. This one is different winning, different winning. So we have three types here. You have homozygous dominant, you have heterozygous dominant, you have homozygous recessive. There's no such thing as heterozygous recessive. Because if it is hetero, means it's different already. Different means for sure dominant. So this doesn't exist. You get me, Get me that. When you are recessive, you are for sure both also short one. You short law. Nothing we can do, right? So let's look at our list of genes. Who are the winning genes and who are the losing genes? Okay, out of these dominant genes, see how many you got. See how many you got. Okay, number one, you know what is free earlobe? You know it's free earlobe. Okay, let me show you earlobe. Let me show you earlobe. Okay, look at your ear. Look at your ear. Is your ear sticking one like the right left picture, or are you the one with the free one? Can you see the difference? Can you see the difference? I mean, this is something that we don't really care. I mean, you don't really care, but just something for you to look at it, lor. So are you attached or free? Usually, if you're a Chinese, usually it's attached one. Us Asian, we are mostly attached one. I don't know, mine is attached at least. Feels like free. You look at the mirror, you see lah. Okay. I mean, if yours is very free, you look like Buddha already. Right? So mine is attached, so mine is recessive already. Right, you're like Buddha already. Shit, I'm going to hell. Okay, so see, so this is free. Mine is not free. I didn't kena already. So see how much you got. Lor. Okay, second one, ability to roll tongue. Can you do this? If you can roll your tongue, then you're dominant. Okay, you're dominant. Most people can roll one. Most people can roll one. Because throughout my 13 years of teaching, I've so far only met like 20 something students who cannot roll one. Okay. I always laugh at them. You cannot roll, you okay, you chat, because you cannot roll your tongue. Okay, anyway, next. Yeah, I chat my ear, I also okay you lah, right? Okay, so next, presence of dimples. Do you have dimples? I don't have. Okay, so if you're a girl, you have dimples, then you look very sweet. Okay, you look very cute. I don't have it. Okay, I don't have dimples. Okay, next, curly hair. Do you have curly hair? You see, mine is straight AF. So I don't have curly hair. Right? If you marry an African or any black skin one, they usually have curly hair one, like very curly. Yours straight, so yours is recessive lor. Okay, so no curly hair lah. Usually us Asians, we are curly, we are straight one. Usually lah. Even if you are a Chinese, if you are curly, you are only a little bit curly compared to your Malay friends. If you compare to when your Indian friends, your Indian friends are very curly one. Okay, so ours is straight. Next, black hair. This one I got. This one I got. Okay. Recessive is brown or golden hair. Okay, so now you're wondering, sir, I thought golden hair. Some of us, okay, most of us loves golden hair, right? You look at Guilo, you say, wow, so nice that they have golden hair. But why are they recessive? Guys, whether you find something, yes, blonde, whether you find something attractive or not, or whether they are recessive or dominant is completely different thing, right? Someone might hate curly hair. Okay, someone might hate curly hair, but hey, but it's a dominant gene. So whether it's dominant or recessive or it is attractive to you or not, it's completely different story, right? What about long eyelashes? This one I don't have. My eyelashes is very, very, very short. If you can hang a rubber band here, that means your eyelashes is very long. Okay, and then next, brown or black eyes. This one we got because we Asians, we all brown eyes, black eyes one. See, blue eyes is only for quite low one, right? And then tall, this one at least I got a lot of big low. So we see out of like 8 here, I got 4. 50 marks, right? 50 marks. Hey guys, just because you get all of it, doesn't make you attractive, because you could hit all of it, people can still find you ugly one. right? And some people, they don't hit any of it, you still find them attractive. Like I said, whether someone is cute or not to you, or whether it is dominant or recessive, is a completely different thing, right? If the guy is very tall, but you find him really ugly, then ugly he is. You don't want him as your boyfriend, no matter he's like 180 tall. Okay, you get what I mean, huh? So this is just to tell you, okay, when these exist, these will lose. They will fight, they will beat this gene and they will all lose. Okay, cool. Cool, huh? Cool, huh? So I think that's it for today, lah, huh? That's it for today. Next week, I will teach you how to draw this, right? If you ask me, sir, if my dad is very tall, big T, my mom is very short, small T, what is the chance that I will be tall? This is the main part of this chapter. I will go into this next week. I will teach you how to draw this because it is very important. Okay, so I hope you learned something new today. Okay, it is a very interesting lesson. Okay, next week will be more interesting. Okay, I will continue with this next week. Okay, so wish you have a happy Wednesday. Okay, have a good one. I will see you next week. So take care. See you and goodbye.